Hey, so I'm hoping that you will make sure you're on page 209 of our workbook. And I just want to start with some basic logarithmic equations. We'll continue to build up, but let's just start with some easy ones. So on problem number 1, it's telling us log base x of 32 is 5. So if you remember from our conversation in class, we talked about how logs and exponentials are inverses of each other, and this is asking a question. X to the 5th power is 32, so what is x? All right, so if we rewrite this in exponential form, it's saying x to the 5th equals 32, and we're being asked to figure out what x is. So most powers get big pretty quickly, so it would be safe to start with 2 and build our way up. So let's just try it with 2 and see what we get. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's it. So 2 to the 5th is 32, and so x is 2. All right, number 2. This, again, if we write it in exponential form, because we're familiar with that, this would say the base 3 of the log stays the base of the exponential, but then these two just flip-flop position, so it becomes 3 to the 3rd equals x. Well, that's nice. That doesn't require much thought on our part. We just need to figure out what 3 to the 3rd is, and that's what x will be. So we get x equals 27. Okay, well, now we get into fractions, which we all have strong feelings about, one way or the other. Right, so if we rewrite it in exponential form, again, the base of the log becomes the base of the exponential, and then these two flip-flop positions. So this becomes 3 to the x equals 1 over 81. Right, as we discussed in class, we don't like it when we have a whole number and a fraction, and so we're going to try and make it so that they're both whole numbers or both fractions. And again, our preference was that we would make it both whole numbers. So we're going to rewrite this as 81 to the negative 1st. Again, if we think about 81 to the negative 1st, that negative 1 indicates flip the fraction over. We'll get right back to that. All right, so now if you remember these, we said, okay, if we have different bases, our job is to try to get them to the same base. And 81 is a power of 3, so we'll just rewrite that. So we'll say 3 to the x equals, right, then this is 3, again, 3 to the 1st is 3, to the 2nd is 9, to the 3rd is 27, to the 4th is 81. So this is going to be 3 to the 4th to the negative 1. Right, again, remember we talked about doing that swap that made sure that these two were exactly equal to each other. And then we can't forget that negative exponent out there. So let me just come up here. This says 3 to the x equals 3 to the negative 4. Right, and that indicates that x has to be negative 4. All right, let's just do one more of these. Let's go down to problem 10. I think that these are pretty straightforward and you shouldn't have too much trouble with them. So this says, again, the base of the log becomes the base of the exponential, and then these two flip-flop positions. So it's going to be 4 to the x equals 256. And again, we want to make this into this base right here. So we would just say 4 to the x equals, well, this is a power of 4. So it's 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So it's 4 to the 4th power. So then that means x is 4. All right. Okay. You can try some of the ones on that page that we didn't do on your own, but I want to move on to something a little bit harder, and that is, again, still not as hard as we're going to get, but a little bit harder than that last page. This is page 210 from your workbook. I'm going to skip over number 1. Oh, actually, no, let's do that. So this says the base of the log becomes the base of the exponential. So 5x becomes our base, and then these flip-flop positions. So this is 5x to the 1st is equal to 25. Well, 5x to the 1st is just 5x. So really it says 5x equals 25. And now we're just back to something algebraic, and so we just get x equals 5. All right, let's look at this one, number 2. So again, the base of the log becomes the base of the exponential, and these two flip-flop positions. So this is 3 to the 4th equals x plus 3. Right, again, we just said that 3 to the 4th is 81. That's x plus 3. And then we subtract 3 from both sides, and we end up with x equals 78. All right, number 3. The base of the log becomes the base of the exponential, so we have 7 to the 2x plus 6 equals 49. Again, just as we did when we had things like this, when we were working in exponential functions, we said, let me change this, the larger one, into this smaller base, if that's at all possible. It is. And so we're going to have 7 to the 2x plus 6 equals 7 squared. Right? Because these two expressions are equal and the bases are equal, that means that the exponents must be equal. So 2x plus 6 must equal 2. We subtract 6 from both sides, we get x equals 2x equals negative 4. And then we get, I should have done that up here, 2x equals negative 4, and then we get x equals negative 2. All right. Now, I know we said we should check logarithmic equations to make sure that we are not getting an extraneous solution. And again, this is the first one where we've gotten a negative. Actually, we did on problem 3 before, but let's just check it to make sure that we're okay with this. Again, it's this part that we really would need to be concerned about. I'm not as concerned, but I just want to show you again how to check that. So if we were to check it, it says log base 7 of 49 equals 2 times negative 2 plus 6. All right, well, again, this is saying 7 to what power equals 49? That means this is 2. And then when we multiply this out, 2 times negative 2 is negative 4, plus 6 is also 2. All right, so that one's not extraneous. Again, we will come across others where we definitely need to check for extraneous. I'm not that concerned about the ones here. Okay, how about this one? We've got the base of the log becomes the base of the exponential, and then we flip-flop the position of these two. All right, so think about what you would do right now. All right, hopefully you're thinking, I need to get rid of this fraction, so I'm going to write 1/16 as 16 to the negative 1st. Right, now you're saying probably I need to get those two bases the same, so I'm going to rewrite this as 4 to the x minus 5 equals 4 squared to the negative 1st. Again, you might be to the point where you're saying, I don't feel like I need to write this step, then I'm just going to write that as 4 to the negative 2. Which is fine. At some point you'll be ready for it. If you're not, then write that first and then distribute that negative 1 into that. That's how you're going to get the negative 2. All right, so then we come down to an algebraic equation. X minus 5 equals negative 2. Again, this exponent has to equal this exponent. We add 5 to both sides and we get x equals 3. Okay, how about, let's take a look at number 9. So this is going to say the base of the log has to become the base of the exponential, and then these two flip-flop positions. Don't forget that we're squaring this whole thing, so don't just write it next to the x and think that it's just x squared. It's also the 2 that's going to get squared. All right, so we get 4x squared equals 144. We divide both sides by 4. We get x squared equals 36. All right. Then we get x equals plus or minus 6. I spoke too soon. We actually are going to have a problem here. All right, so here we do need to check to make sure that we're okay, because one of these is actually not going to work. So if I plug x back in, I'm sorry, yeah, if I plug 6 back in, I'm going to get log base 12 of 144 equals 2. And that's totally fine. 2 to the second power is 144. But if I try it for the negative 6, then I get log base negative 12 of 144 is 2. All right, we are not allowed to have a negative base. All right, that's just not possible. And again, we'll talk about that a little bit more. I'm pretty sure we said that in class, but I'm not 100% sure. So if we haven't, we'll talk about that together in class. But this is not allowed. So only x equals 6 is the solution there. All right, we cannot have negative 6. Okay, hope you feel good about those. All right, see ya.